Hello, my precious friends. I really hope that you are doing great. Welcome to today's class. It is our first lesson on the sixth topic of Form 4, which is called mains electricity. As usual, let me commence by giving the quote of the day, which states that success is not an event, rather, it is a continuous journey that requires self-discipline, consistency, and evaluation. We shall discuss that quote at the end of our class today. So today we're looking at the mains electricity. Remember, mains electricity is simply a form of electricity that is supplied from the power stations to the household. Then it is also important to remember that mains electricity only operates on alternating current. The reason being it is easier to step down and also to step up alternating current. So that simply means that in mains electricity we don't use a steady direct current. The reason being it is impossible to step down or to step up the steady direct current. Now, let's look at some of the main sources of electricity. The first source is what we call that is water in high dams. So remember that the gravitational potential energy of water in high dams is usually converted to kinetic energy. That is whenever water is released through some waterfalls or through some narrow streams. So the gravitational potential energy that was possessed by the water, which was held in a dam, when it is released, actually that gravitational potential energy is converted to kinetic energy. That is when water is moving through some waterfalls. Remember, energy in motion, that is kinetic energy. So when it is converted to kinetic energy, which is used to rotate the turbines of a generator. Remember, we can be using either an alternating current generator or a direct current generator, but we have said that for the case of mains electricity, we prefer using alternating current generators because AC, that is alternating current, is easier to step it down and also to step it up whenever we need to transmit it from the power stations to maybe to the local substations and also to the households. So the gravitational potential energy of water in high dams is converted to kinetic energy, which is used to rotate the turbines of a generator. Now remember, the turbines in turn, they rotate large coils which are placed perpendicular to the magnetic fields of a magnet, of course, within that particular generator. So remember, whenever a conductor meets the magnetic field lines at an angle of 90 degrees, then we expect some EMF to be induced, just like in the way we discussed the working of an AC generator and also the DC generator. So we had a coil being rotated within a magnetic field whereby we expected some EMF to be induced in that particular coil. So the only difference is that what we are using to rotate that particular coil is actually the kinetic energy of the water in the waterfall. So that kinetic energy, which is used to rotate the turbines of the generator. Then the turbines in turn, they are connected to the coil of that particular either AC generator or the DC generator. So the turbines in turn, they rotate large coils placed between the magnetic fields of a magnet. Then of course, whenever a coil or a conductor is rotated within a magnetic field such that it meets it at an angle of 90, then we expect some EMF to be induced. So this induces EMF in the coil, hence producing electricity. Then the second source of mains electricity is what we call the geothermal energy, whereby we are saying that the high pressure steam from underground is used to rotate the turbines of the generator. Of course, the turbines in turn, they rotate the large coils placed perpendicular to the magnetic fields of the magnet. So this induces the EMF in the coil, hence producing the electricity. Then the third source of mains electricity is what we call the nuclear energy, whereby you are saying that energy from nuclear reactions, they generate heat used to boil water to steam, of course, under very high pressure. So when the steam is under very high pressure, it is used to turn the turbines of the generator. Then remember, the turbines of the generator in turn, they rotate large coils placed perpendicular to the magnetic fields of the magnet. So this induces EMF in the coil, hence producing electricity. Our fourth source of mains electricity is what we call wind or moving air. So remember that the wind energy is converted into kinetic energy in the windmills. Remember, when the windmills are incident on wind that is under very high velocity, the windmills will start rotating when they get in contact with that particular wind that is in very high velocity. So because the windmills are moving, that is energy in motion, which is kinetic energy. So the wind energy is converted into kinetic energy in the windmills, which are used to rotate the turbines of the generator, because the windmills are connected in such a way that they get in contact with the turbines of the generator. Then we know that the turbines in turn, they rotate the large coils placed perpendicular to the magnetic fields of the magnet. Of course, this induces EMF in the coil, hence producing electricity. Our fifth main source of electricity is what we call the tidal waves in the sea, whereby we are saying that the tides are used to rotate the turbines of the generator. Then, of course, the turbines in turn, they rotate large coils placed perpendicular to the magnetic fields of the magnet. So this induces EMF in the coil, hence producing electricity. Then, of course, our last source of mains electricity is what we call the fossil fuel. So examples of fossil fuel include the coal and also the diesel, whereby we are saying that energy from burning fuels, remember when you burn coal or diesel, that energy is used to, it generates heat. So when you burn them, we have some heat that is going to be generated. So energy from burning fuels, that is fossil fuel, generates heat, which is used to boil water to steam, of course, under very high pressure. So the steam under very high pressure is used to rotate the turbines of the generator, which in turn we know that the turbines are connected in such a way that they will rotate large coils placed perpendicular to the magnetic fields of the magnet. Of course, this induces EMF in the coil, hence producing electricity. Now, next, let's look at the power transmission. That is, how do we transmit power? Whereby we'll start by defining what we mean by the national grid system. So we are saying that national grid system is simply a network of transmission cables connecting all power stations in a country to each other and to the consumers. Why is it important to connect all these power stations or the power source stations in a country? The reason is because so that it ensures that power is available to consumers or to all consumers even when one of the power stations fails. Yeah, for example, maybe we get into a drought season, so that means water in the high dams is actually going to be very low, so hydroelectric power will not be produced in that particular case. So when there is drought, the water in high dams is going to dry, therefore it will be impossible to produce electricity using the hydroelectric power. So in that particular case, when it is dry, we can have, maybe it is dry, yes, but we have some wind moving at a very high velocity. So because the national grid system is interconnected to all these sources of main electricity, even if the water in the high dams, it actually gets dry, the energy is still going to be produced by the windmills. So because the windmills are still working, that means the consumers will still get the power supply, of course, from the national grid system. So it is important, the importance of national grid system is that it ensures that power is available to all consumers even when one of the power stations fail. Now remember, if there was no national grid system, it simply means that in a region whereby we have the water that is in high dams or hydroelectric power generation, then it simply means that when the dams actually dry, you are going to have a lack of electricity in that particular country, or we are going to have what we call a blackout. So to prevent that, we introduce what we call the national grid system, which is a network of transmission cables connecting all power stations in a country to each other and to the consumers. So that ensures that power is available to all consumers even when one of the power stations actually fail. Next, we look at high voltage transmission. So this is simply a summary of how power or electricity is produced from the power stations and of course transmitted to the local substation and to the final consumers. So the final consumers could be heavy industries, it could be light industries, it could be hospitals, villages, schools, and other social amenities, for example, the churches. So within the power station, we have the generator. Within that particular power station, we also have the step-up transformers. So remember, when we were discussing about the main source of electricity, we talked of maybe the use of water in a dam. We also talked of that is the windmills or the wind energy. We also talked of the fuel fossils, whereby we said that these particular sources of mains electricity, they simply help us to turn the turbines. Then of course, when the turbines are turned, they are simply connected into the coil of a generator. such that as the turbines rotate, they cause the coil of the generator to also rotate within a magnetic field, hence an EMF is induced. So an EMF is induced in these particular generators, which in most cases we can use the AC generators because it is easier to step up and also to step down the AC current. So within the AC generators, of course, as the coils are turning, an EMF is being induced because the coil is placed within a magnetic field, such that as it rotates, it meets with the magnetic field at angles of 90 degrees. So that induced EMF within the generator of the power station is usually at very low voltage and very high current. So electricity generated at the power station is usually at very low voltage and very high current. So remember, if you transmit electricity or power at very low voltage and high current, you are going to experience very high loss of power on the way before it reaches the substations or to the final consumers. Therefore, because the electricity produced at the local power, that is the power station, is at low voltage of about 11 kilovolts, we therefore need to step it down so as to minimize the power losses on the way. So within the power station, we also have a step-up transformer, which will step up the voltage from 11 kilovolts up to 132 kilovolts. So before transmission, the voltage is stepped up to very high voltage and very low current. Remember, voltage and current are inversely proportional to one another from this particular formula, P is equals to VI. So you can see voltage and current are actually inversely proportional to one another. So when the voltage is high, the current is low. Then of course, when the voltage is low, it simply means the current is very high. So before transmission, the voltage is stepped up to very high voltages and low currents. As you can see, the voltage that was generated from the generator was actually 11 kilovolts. Then it is being stepped up by this particular transformer, the step-up transformer within the power station. It is being stepped up from 11 kilovolts up to 132 kilovolts. Remember, the transmission cables that are used to transmit that is power at about 132 kilovolts or at very high kilovolts, we call them the super grid. The super grid is usually connected in such a way that the cables or the connection cables are very high from the ground. So the reason why the super grid is connected very high from the ground is to reduce the dangers of an electric shock. Because remember, 132 kilovolts, these are very this is power at very high voltages, so it could have some effects of electric shock when it is connected, when the cables are connected near the ground. Therefore, the super grid is usually connected very high from the ground level to reduce the effects of such as maybe the electric shocks. Then of course, from the power station, the power of course is supplied from the step-up transformer. Then it is supplied to the substation, that is the local substation, before it goes to the final consumer. So at the substations, we have what we call the grid. So the grid, these are usually connected relatively closer to the ground because they are carrying low voltage power as compared to the super grid. So the super grid are usually connected very high from the ground to reduce the effects of electric shocks. So within the substation, we need to step down this particular power. Remember, the purpose of stepping up was simply to reduce the power losses in the process of transmission, whereby you are saying that before transmission, the voltage is stepped up to very high voltages and low currents. So we are saying that the mains electricity is transmitted at very high voltage in order, the reason is to minimize the power losses. Since the power dissipated in a circuit is usually given by P is equals to VI, then the power loss in those particular transmission cables will be given by I squared R. Remember this formula, we derived it, that is in a given topic in Form 3, which was called the heating effect of electric current. You can just refer back. So the power loss is given by I squared R, of course, where I squared is the square of the current, then R is the resistance in those particular transmission cables. So from this particular formula, that is power is equals to VI, if I make V subject of the formula, I'll divide both sides by the current I, so that simply means V will be equal to power over the current. So from this formula, if I hold power constant, it simply means that the voltage is inversely proportional to the current. Therefore, the higher the voltage, the lower the current. And of course, so we are transmitting this particular power at very high voltages. So when the voltage is high, it simply means that the current is very low. And remember, power loss is given by I squared R. So if the current is very low, it simply means that the power loss in those particular cables will also be very, very low. So the higher the voltage, the smaller the current, because you can see here from this formula, V is equals to P over I. Voltage and current are inversely proportional to one another. Therefore, the higher the voltage, the smaller the current. Hence, less power is lost in form of heat, because power loss is given by I squared R. So that simply means that if current is very small, then the amount of power that is going to be lost will also be very small, because you are multiplying a smaller current with a resistance. Of course, the final result would be a small loss in power. So that is the reason why we transmit power at very high voltages and low current. So the reason is to reduce the power losses on the way. So hence hence less power is lost in form of heat on the way. So we transmit the power at very high voltages of about 132 kilovolts. Then of course in the substation we step down that particular voltage. So we'll step down the voltage from about 132 kilovolts to about 33 kilovolts. Of course, different industries will need different amount of power and of course amount of volts. So for example, for heavy industries, that is industries that are used in maybe manufacturing. So maybe for example, industries that manufacture things like steel, they need very high power or very high voltages. So we are going to step down the voltage from about 132 kilovolts to reduce the risks of electric shocks. So we step it down to about 33 kilovolts, which is applied to the heavy industries. Then of course the remaining will also be within the substation. We are also further going to step it down from about 33 kilovolts to about 11 kilovolts to go to the light industries. Remember, the light industries do not need a lot of power as compared to the heavy industries. Within the local substation, we are still going to step it down to about 11 kilovolts. Then of course we can step it down to maybe even smaller voltages, maybe to about 5 kilovolts. Maybe in maybe some villages will need very low voltage of about maybe 4 kilovolts. Yeah, so it will depend with the electrical instruments that are within that particular the local substation or that particular village. So remember that in the substation we use special cables which are called the grid. So the grid are usually connected relatively closer to the ground because they are carrying low amount of voltage. Therefore the electric shocks, the probability of electric shocks is very, very low. But for the case of supergrid, they are connected very high in the ground because they are carrying very high voltage. Therefore there could be risks of electric shocks. So this is what happens in the local substation. We have stepping down of power to light industries, hospitals, villages, schools, and even churches or any other social amenities. So the key things to note here is that you can be asked to give a reason why before transmission the voltage is usually stepped up. So the reason is because it is stepped up to very high voltages. So the reason is to reduce power losses in form of heat. And you have said that it is reducing power losses because when the voltage is very high, the current is very low. And from this particular formula, the voltage is high, the current is low. If the current is low, the power loss will be I squared R. If the current is very small, the power loss will also be very, very small. So at the consumer point, of course, the voltage is stepped down as shown in this particular several step down transformers. Next, the output voltage from a power station is stepped up for long distance transmission in order to minimize power loss in transmission cables. So since long distances are involved, transmission cables are usually made thick. The reason is to minimize electrical resistance, hence reducing power losses in form of heat. So remember, under a given topic in Form 3, which was called Current Electricity 2, we did derive this particular relationship. That is the relationship between electrical resistance, length of the conductor, and of course the cross-sectional area. Then we had a constant called resistivity. So from this formula, it is clearly evident that electrical resistance is inversely proportional to the cross-sectional area of the conductor being used. So because we are using thick conductors, so remember a thick conductor has a larger cross-sectional area. Then we said that thick conductors or conductors with larger cross-sectional area, they have more number of electrons per unit area. That is why their conductance will be very high. Remember, when conductance is high, electrical resistance is very low. So conductors with very large cross-sectional area or thick conductors, they have more number of electrons per unit area, which are responsible for carrying the electricity from one point to another. So if conductance is high, that simply means that their resistance will be very low, hence they would reduce energy loss in form of heat. And we are also saying that they are made of materials which are good conductors of electricity, such as copper and also aluminium. And we are saying that aluminium is preferred for use in long distance power transmission cables because of the following three reasons. So the first reason is that aluminium is a good conductor of electricity, just like copper. Then the other reason is that aluminium is very, very light, meaning that it is easily portable, so the probability of it falling down when it is connected very high from the ground is very low, as opposed to other conductors, for example the copper, which is usually somehow heavy as compared to aluminium. Then the third reason why we prefer using aluminium is because aluminium is cheaply available on the market. Then we are saying that it is impossible to step up or to step down steady direct current voltages. This is the reason why we don't use direct current voltages in the mains electricity. Because remember, in the mains electricity, we need to step up the voltage from the power station when we are transmitting them to the local substations. So the reason is to reduce the energy losses on the way, that is from the local substation to the local substations. So that simply means that if you use a step down, that is if you use direct current voltages, you won't be able to step it up or to step up the voltage. So that simply means that you are going to experience high loss of energy on the way, that is from the power station to the local substations. Then we are saying that this is the reason why alternating current is used in mains electricity. The reason is because alternating current can easily be stepped up or stepped down. Remember, the importance of stepping up the voltage from the power stations to the local substations or to the local transformers is so as to reduce the power losses on the way. So if we use alternating current, we'll be minimizing power losses on the way, because that current, the alternating current, can easily be stepped up or stepped down whenever required. Then we are saying that the dangers of high voltage transmission are the following. One, we have the risk of electric shock in case the poles collapse or the cables hang too low. Then the other danger, we have the risk of fire on nearby structures and vegetation when cables get too close. Then the third danger is that we have harmful effects of strong electric fields. So we've come to the end of our class today, but we need to discuss the quote of the day. The quote of the day stated that success is not an event, rather it is a continuous journey that requires self-discipline, consistency, and evaluation. So the quote is reminding us that overnight success is a myth. We should therefore be ready to work on our dreams over a long period of time without expecting instant results. Recall that true success is when you enjoy the process of pursuing your dream as opposed to actually achieving that particular dream. Yeah, you should do something that you enjoy doing it. That is, you enjoy the process more than even the results. Because if you are enjoying the process, you will be able to do it over a sustained period of time without actually giving up. And lastly, remember to balance your ambition for success and your patience for success. Thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kind Tuition Academy. Thank you very much.